right, welcome back to Coffee Talk with me, Karen B. It's so nice to see you all here again this fine Moonday morning. It is December 5th, 2022, and it's getting colder. It's that time of year. It's rainy, it's gloomy. How is everyone doing this fine day? So I made the right choice on not going on David Rodriguez with Archaics. Yes, DITRH, absolutely, you made the best choice. Let's see. Let me say hi to you all. Louis Russell, first in chat, coffee and flat earth. Let's go, baby. Yeah, Spicy Sarah, commercial sound and video. Hello all. Three Fingers, Mark Shuri, Grounded Extracts. Hello, James and Najla. James and or Najla. Sherry Ives, National Memorial Gardens, Ollie Rendon, Melodome, Effie Nation. Effie Nation, I was digging out my protractor from my files. I'm going to talk about that a little bit today, along with a couple of other things. I've got a lot to talk about today. We'll see. It should be a nice, chatty Monday morning. I'm feeling chatty. J Craft, BCB, Tom Etchison. It's a good day to drink coffee and not abide by the man. That's right. Yeah, there were a lot of chemtrails at the baby shower. Voynich, good to see you. Lloyd Elling. Thank you, BCB. Sarah Breslin. Good times for all. I like that I'm starting to see some new names in here in the chatting. I love this. This is great. This is what we need. We need some new names. Come on, buddy. I love it. I love it. Let's build that flat empire. Build that shit. Build it. All right. Who else is in here? Chris Shizpak. Be strong and of good courage, fear not, nor be afraid of them, for the Lord thy God, he it is that doth go with thee, he will not fail thee, nor forsake thee. Very nice, thank you. Although I don't like using Lord or God. That should say for them, for Yehovah, blah, blah, blah. But we won't get into all that. Mystical Grounding Fossils, good day. Mystical Grounding, Rock Hounding. Effie Joss. Cammy, hi Cammy. Enoch 7th, Adam 1st. Doug McMullen. Kim Ray. Lots of good people in here. Ashley Knopp, Mark Wontraba, Cody Ford over here on Rockfin, along with Brian BCB. Brian CB. And I'm also streaming on Odyssey, although I don't see anybody in chat at Odyssey. And of course, I'm on Facebook. Oh, which I forgot to share my stream. So let me go ahead and do that right now, before I forget. One sec, I'm sorry. Whoa, what? Did Flat Earth News and Reports get changed? United for Good Information? Is that what that is now? This is no longer Flat Earth News and Reports. It says United for Good Information. Who changed that? Oh, well, I mean, whatever. Whatever. Weird. Anyway. Pancakes and coffee. Yeah. Zach again. Yeah, so we had a baby shower for Kai and Austin Whitsitt over the weekend. On Saturday, we had everybody come join us. It was a good time. Let me see if I can pull that picture up for those of you who aren't on Facebook. Let me see if I can upload these and share them. So yeah, we had a bunch of people come up. It was really cool. Let me see here. Sorry, I'm just trying to upload the photo so I can show it to you guys. All right. So, let me go to my share screen mode. It was really cool. Baby shower. Here we go. See if we could show it. There we go. So there's Star Hills, James and Najla back here. There's Crystal. She's a local lady from North Carolina. There's Eric, Carl, Vinny, Tommy, and then the Boltons, some of our newest members of the FE crew in the Carolinas. They do the food truck. If you've seen the commercials on Strange World, that's their food truck. And then, of course, right there in the middle, the couple with their newest Flat Earth baby on the way, Kai and Austin, looking cute. And then, of course, lots of Flat Earth babies that are already here running around. It was a good time to be had by all. There we go. There's Sarah and Griff, their baby. Here's all the babies. We had it was cool. It was a good time. We had the clubhouse. Law made some really cool food. Oh, I got to show the video of the food. Hold on. Let me upload this. I just took a quick video. It's not super long of the little spread that Law had going over there. So let that upload and then I'll show it to you guys. But it was really fun. So thank you to everybody who came out and supported and brought gifts for the new baby on the way. I'm trying to put pics out. Here, hold on. Here we go. That was a pretty good game. Are you guys ready to eat? That is so cute. Is that yummy? Is that yummy? Yummy? The fancy pineapple. The fancy cantaloupe. So there you go. Here, I'll mute it and let it play one time. But yeah, it was cool. More Flurf babies. Yes, we are more Flurf babies on the way. Exactly. Exactly. Yes. Yeah, so that's what we did this weekend. It was fun. Good time. It's a good time. So yeah. Yes, it was very nice. Very nice. Yeah, dude, Dr. Law does everything. And then he tells me never to say his name and to never, never say, don't say my name. Like he sets all that stuff up and then cooks all the food and has people, people help him and stuff. He's got help, but he does a lot of stuff on his own. And then he's like, don't say my name. And then of course, whenever I go announce the money that was raised and we're giving it away, his name just comes out of my mouth. It just comes out. I can't help it, but because that's who's doing it. That's where the work is coming from. Like, I don't know how I'm supposed to like not say your name. It just comes out. I don't know what to tell you. Yeah, it was awesome. Yeah, so I'm sorry, Law, if you don't want me saying your name, but I mean, what am I supposed to do? Yeah, yeah. Grand Rising, Sam Clint on Rockfin. Good to see you. Um, I'd rather be a flurf than a blurf. What's a blurf? Is that a ballerfer? Is that like the ballerf? I haven't heard that term yet. Yeah. You know, we all do it as a group. Try to take care of our people around here. We try to have a good, support group around here because it's important, right? It's important to have a good support group and not, be feeling alone. Yeah. He's always there. He's always there in the background. I was even looking, okay, because I'm starting to get I've gotten a bunch of the video from the HD video from David Glennie, right? Who, so I'm going to play one of these things for you. Let me see if I could do it. Where is it? Oh, it's on the other hard drive. But, let's see. Where was it? Maybe it was at the end of one of the presentations. Or was it at the end of... I can't remember. But anyway, I was announcing the... was it the end of this Jason Lindgren one? Nope. Anyway, I was announcing the money's being given away, and then I said Dr. Law's name. Right after he tells me not to do it, every time. Every time. Anyway, whatever. So, okay, let's talk about this first before we get into the ranty rant type stuff, I guess. So there's been some stuff going on. Like there's a video that Taboo Conspiracy put up. It was a mirror of somebody's presentation that says magnetic declination doesn't exist. I adamantly disagree with that statement. But I get why that guy thinks that. And I know he's like I sailed around the world type of guy, but he's still wrong that there's no declination. Anyway, I don't know if you guys remember. Oh, where did I put it? I don't know if you guys. Oh, there it is. Okay. I don't know if you guys remember way back when. Let me go back to screen share mode. All right. I don't know if you guys remember way back when we were doing sun tracking, where we would do 24/7 live stream, or not 24/7, but a 24-hour live stream, where we had different people all over the plane participate in sun tracking, right? And the whole point of the sun tracking then was to see where solar noon was, according to, where it should be on the map. Like we were trying to figure out, if the sun was actually following just trying to measure the lights in the sky to see if what they're doing matches what we're being told, right? Now, that being said, some of the places did get sunrise and sunset and solar noon and stuff at times that we didn't expect, but for the most part, it was pretty much there wasn't really a whole lot to be gleaned from that, because it's so difficult to tell you can't define the shape of the Earth by looking at the lights in the sky. I mean, we've all already been through this many times before because because we've been here for a long time, and that's what everybody says. Oh, but everything else is a ball, right? So how come Earth is different than all the other planets, right? Well, because Earth is not a planet; it's a plane, right? It's. I mean, we know that now, but that is still to this day a major argument for the globalists is the lights in the sky, right? Well, not that I'm trying to argue against globalists in this whole discussion. It's not what this is about. What this is about is that magnetic declination is a thing. Now, where I do agree with that guy's video is that there is somewhere hidden in the magnetic declination is part of the deception between the globe and flat Earth, right? There is something there. But I don't think it's what he thinks it is. That's where it's different. But I do think there is some deception in the magnetic declination. And this is why I'm bringing out this protractor again, because, in fact, let me bring up my other protractors that I actually did measurements on to show, what I'm talking about. Okay. So on this sheet right here, okay, this thing right here, this is how you measure the sun angles, right? Or you track the sun. So in the center here, in this center point, the directions on here tell you to put a nail, a 5 centimeter nail. Now, you don't have to use the 5 centimeter nail, but if you use a 5 centimeter nail on this protractor, then the given angles, the angles have already been figured out for you here, and you can just look at the chart. You can also just use the mathematical formula for figuring out the angle, which I can't think of what it is right now, but it's like, the angle with the stick and the blah, blah, blah. But, I'll bring that up later if you guys want to see it. But you just use that mathematical formula where you punch in the height of your gnomon, which the nail in the center of the protractor is acting as the gnomon on a sundial. Like, when you have a sundial and then you have that thing sticking up and the shadow that casts tells you the solar time, right? So it's the same principle. You put the gnomon or the nail, your stick, in the center, okay? Anytime you're talking about sticks and shadows to measure angles, the stick is the gnomon. So if somebody says, if you see that word gnomon, stick, measuring angles, sticks and shadows, okay? It's all the same thing. So you put your 5 centimeter nail in the center, okay? And then you align this whole thing to north. You have to use your compass to align it to north, okay? So you align this north here to magnetic north, okay? And then you start tracking the sun, the shadow of the sun. What that looks like is like this, right? So here's your nail, and the sun will be behind you, and it's casting the shadow up this way, right? And so then you're just marking a dot every few minutes right here on your protractor where the end of the shadow is, where the shadow cast by your gnomon / nail / stick. You just tip the end of that shadow as the sun moves along throughout the day, right? And then you start to see it going across here, right? And then you have your protractor already measured out with the measurements from the center out, telling you the length of the shadow, right? So there you go. Because it tells you right here, 1 centimeter, this line here is 2 centimeters, 3 centimeters, 4 centimeters. So, and then every line in between is a millimeter, right? So this is telling you how long your shadow is just by marking it on this protractor. That's what makes it so easy. That's why we use the protractor. You align it north, and then you just tick the end of the shadow as the sun moves along in the sky throughout the day. Okay? Now, as you can see, when we were doing it, you're sitting there for a while. It's a pain in the butt. You are literally babysitting your sundial, your track, and you're just sitting there with a pen, and every few minutes, every like 3 to 5 minutes, you just tick that little, and the more often you do it, the more accurate your reading will be, right? So, here's another one. I'll just show you. Okay. Here's another one, what it looks like. Here it is. Just as the sun's going through, just tick, 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 tick. Okay. And then, it's giving you the length right here. Whatever line it hits, whatever part of that circle it hits, then you can just count it and tell how long your shadow is, right? And you got to do it for hours. We would spend literally hours watching the sun, right? Making these little tick marks, okay? So, now, what did we learn from this? Not a whole lot at the time, but what I figured out, or what I thought of when we were doing all this stuff, and why I started, I was also at the same time working with Zach, and we were trying to figure out the map and blah, blah, blah. And he and I we discussed magnetic declination a lot. And he actually had an experiment that he wanted everybody to do, and it was called Globe Earth versus real life, right? So like where you can go on Google Maps and you can set your point there, and you can, pick an azimuth or a degree of deviation from 0, right? And then look at a point, and it'll say you, this is, X amount of degrees from this point, and then it'll give you an angle between, right? So, but that map is laid out on a globe. So what we wanted to do is to have people go to these physical locations, or what Zach wanted to do is have people go to these physical locations where you could see distant landmarks, right? Because the farther off you see, the better data you're going to get if you use a bigger area, right? So you would have to go to these distant areas and have a compass, a directional compass, like a military directional compass. You have to have a protractor. You have to, and sit there and manually measure the degree of difference, the visual degree of difference between these 2 points, and then compare it to what it tells you on the map. Now, how many people do you know who are willing to take the trouble to go do this? It is very tedious, and it's kind of complicated. Most people will look at doing, like, if you ask most people to go do something like this, they're going to look at you like you have 2 heads, And when Zach put this stuff out, I was the only one who actually went out and recorded information where that could be used in that experiment. I was the only one. Nobody wants to do this stuff. Okay? This isn't fun. But this is what it takes. This is the type of stuff that, you have to do to really get a good grasp of what is really happening in reality versus what they're telling you. Okay? So my idea is, and I'm talking about this now, and I probably feel like I'm already losing people, but that we do the sun tracking thing again. But with a different point this time. This time I want everybody to manually measure their magnetic declination in their area, and then we can compare it to what the magnetic declination is given to us by USGS, right? So this is what I did with these sun tracking sheets years ago, as I had started making a video about magnetic declination, because there is something there. There is something fishy going on there. So what I figured out at the time was that while we're doing these sun tracking things, right, and measuring the sun shadow, right, and the sun's going behind you, right? Well, if you measure the sun shadow long enough, you can figure out with that, if you have a compass and magnetic north, you can figure out what the actual deviation is between the actual point that the sun is revolving around and the point that the compass is pointing to, which is magnetic north, right? The compass points to magnetic north, not geocentric north, not geographic north, not the actual true physical center. It's following the lines of flux which point to the magnetic center, right? And these magnetic flux lines don't run in straight lines. They're all over the place, which is the magnetic declination. So where is the deception? I think the deception is in what our true magnetic declination is, which is what could be measured manually by tracking the sun and figuring it out, and what they tell you on USGS, right? Because and I feel like it's easy for them to put it there, and it's because of how tedious and what a pain in the butt it is to do this, to figure out the difference on your own without machinery or without relying on being told by some government agency what it is. Because we can figure this stuff out, but they're never going to teach you this stuff in school. Okay? So, what we could do is if we got enough people all around, even just across the United States would even be enough to see differences, because I measured a difference of about 5 degrees at the time that I did this between what I measured in magnetic declination and what USGS told me my magnetic declination was. So, let's see if I can find these other. Why can't, oh, here we go. Display as a list. Okay, so okay, so let me see if I can use these slides to maybe better illustrate the difference or what I'm trying to explain. I hope you guys are getting this. I guess I'd rather try to over explain than under explain. Okay, so check this out. So here we go. Here is a picture of the United States with a magnetic declination lines overlaid it, right? So, and here is that same picture with a protractor over it. And the protractor, the zero on the protractor has been aligned to magnetic north. Okay? I don't know if you guys can see that. I'm basically trying to illustrate, do a better illustration of what I'm trying to explain. So the zero's pointing to magnetic north, okay? Right? Here, zero's pointing to magnetic north. Magnetic declination USGS, right? So then the USGS says, okay, well, you have to correct your compass, X amount of degrees to the east to be pointing at true north, right? And then here's the magnetic declination that I measured, right? My magnetic declination was told me that it was much more off than what USGS told me, right? So, and by a lot, 5 degrees is a lot. Okay. So, can you guys picture, do you guys get the principle behind this, right? So if the sun is going behind you and the shadow's here, this is how I think you can figure it out, right? The sun's going behind you. As the sun approaches, right? As the sun approaches, the shadow's going to be longer, right? When the sun is lower in the horizon, the shadow is longer. Okay? So as the sun approaches, the shadow gets shorter and shorter and shorter. Now, the shadow is the shortest during solar noon. Right? So, oh wait, let me bring up that one picture again. The sun is the shortest during solar noon. That one. Not that one. Oof. Okay, here we go. The sun is the shortest. The sun's shadow is the shortest during solar noon. We know that, right? So you can see here, it's longer, it's further out, and then as it gets closer, the dots get further into the circle, so that's showing that the shadow is shorter. So as the sun is closest, the shadow is short, right? But then as the sun starts to go around, right, and get farther away again, the shadow then starts to become long again, right? So what I figured out is you go on the protractor, and you can see here, I start looking and I go, okay, well, this dot right here, between this dot and this dot is the sun's shortest shadow, right? It's the shortest shadows. So the beginning, I marked the beginning of the shortest shadow where it kind of rides that line. You can see it kind of rides the outside of that circle, right? So it's like pretty equal in length for that time. Let me see if I can zoom in and make it more obvious, right? So you have this right here, this little series of dots is like riding on the outside of this one circle. So I consider that, you know, that time frame of solar noon. That's the sun's shadow is the shortest, right? And it's the closest to you in your spot. It's like right over your head. So you take that angle, right, of those shadows, whatever that angle is. See, beginning of short shadow, end of short shadow, right? And then you're already aligned to magnetic north. So my idea was, if you divide that short shadow, right? You divide that time when the sun is the shortest in half. So then when you divide that point in half, that's about as close as you can get to pinpointing the actual spot that the sun is going around. Does that make sense? You know, it's geometry. It's basic geometry. I'll have to draw a diagram to like outline this better, to explain it better. But if you take that short shadow time when the sun's closest to being over your head, divide that by 2, and that middle point there should be like as close as you can get, right? So then you take that, and then you take your where your compass is pointing, your magnetic north, that, and then you can measure the difference. See right here? So you divide it in half. This is your manually measured true solar north noon, the sun's absolute shortest shadow, middle of the time, high noon, right? Here's your magnetic north. That difference is your magnetic declination. Okay? Because that's literally the definition of magnetic declination, the difference between where the compass points and geocentric center, north, right? So, I don't know if this was mine or not. I don't remember. This might have been mine, but this is measuring 5, 6, 7, 8, 9 degrees magnetic declination. But I know on my, what did it say magnetic declination was for my area? Or is this Denver? That might be Denver. And then Denver magnetic declination is told, let's see, to be at that time 6 degrees west. Okay, so this is, oh wait, no, it's changing by 6 degrees west. Where is it telling me the declination? Calculate. 8 degrees. Okay, here it is. 8 degrees, 19 minutes declination. Right here. That's where it says it. Okay, and so this is measuring 9 degrees. So that's right on, right? But also, if you look, or at least it's close enough, right? So now, if you look at that magnetic declination map, you'll see here though, where's Denver? Right here, okay? And it does tell you, so here's a 10 degree declination mark. And so right here, it'll be a couple degrees over. So, and it's, you know, so that was pretty right on. Mine was more off. Mine was way off. But anyway, this is what I'm saying. Have I lost you all? Let me check chat. We're with you. Yeah, I see what you say. I'm digging it. Okay, it is a lot. Okay, does it... Am I making sense? The quickening is the sun spiraling towards the center. Right. Okay. But do you see what I'm saying? How we're measuring the shadow to make like a, we're trying to create that shape that's pointing to that spot, right? So anyway, what I would like to do is do another sun tracking where you don't have to necessarily track the sun just for solar noon, because the other problem with some of the data collected from these past sun tracking things is a lot of people stopped right at noon. And what I would like to do is for people to start a little bit before and then go a little bit after, because I want to see that that dot line of the sun going around, and then I want to be able to definitively, or as close as possible, pinpoint that time, that little angle where it's the sun's shortest shadows, that we can then subtract that from the given magnetic declination and see if it matches. This is how you manually match magnetic declination, is what I'm saying. This is how you spot check USGS. And it's a pain in the butt. It's I don't know how many people would actually be willing to do it, because you're going to have to sit there for probably 2-3 hours. It's going to be, honestly, 2-3 hours in the middle of the day to plot those shadows. And then all you would have to do is write your location, right? You're as close to your location, your coordinates or whatever. And then we can go and check and say, okay, your given magnetic declination for your location is this. You measured this, right? And I think it would be interesting to see where those discrepancies lie, where the biggest discrepancies lie between what they tell you your magnetic declination is and what you can physically measure by observing the sun go around in the sky with a compass. Does that make sense? I have to think of a better way to explain this, because I get that it could be like a lot to take in. I get it. I'm on Rockfin too. Hey, Carl. Hey, Rose. I just wrote a status on Facebook that's probably going to get me in trouble, and I want Karen to read it on Coffee Talk before I get kicked off FB. Okay, well, let's go see. What did you do, Rose? Why can't I find you? Did you already get kicked off? Because oh no, there you are. I don't see it. Tag me in it. Facebook is hiding it. Oh, here we go. Never mind, I got it. What is this about? Is this the one, Rose? What is this about, and who is Uncle Elon mad at? It seems like people who should know things are completely unaware that both SIDS and SADS are juice damage. If he killed this child with the juice, then the only person he should be mad at is himself, and they should be honest about their mistake and spread the word. I am so over people using their dead babies to get attention and pull heartstrings for personal gain. We are in a clown world. I could act like the wheelchair guy in The Big Lebowski and remind people about how I lost my legs and shit anytime over from Gardasil and birth control and guilt trip people. But hey, if people want to give experimental poison to their babies, they shouldn't be parents anyway. Just my opinion. Everyone's got one. Maybe they are rolling the dice since it's so trendy to have retard for a baby to exploit on social media. What is this about? A SIDS-related incident that put him on life support. He was declared brain dead, not that it matters, except because it was one of his most sacred and defining moments in my life. What? Wow. Oh, wait, so this is oh, now I get it. A SIDS-related incident that put him on life support. I was the one who was holding him. Ooh. Now I get it. So his baby died, and he's trying to say that the baby died in his arms, but then the mom said, no, I was the one holding him. Wow. What a disgusting POS. No need to do anything. The enclosed flat earth is already proven. I know it's proven. This is not about proving that the earth is flat. It's about starting to unravel where the deceptions are, like how they're doing it. The deception because like navigation and stuff like that, and communication and mapping, these are big points of contention. So don't you think it would be clever to have a way to, I don't know, check their maps? I mean, people should know how to do this stuff, right? So if they just have just a little bit off here, a little bit off there, I mean, they could be doing it just enough to make it unnoticeable in everyday navigation. Do you know what I'm saying? It could be just enough. How does Dead Reckoning disprove magnetic declination? That's not true. How does it disprove what we can manually measure with the lights in the sky, with what the sun does, and a compass? You can't disprove something that you can measure with a compass and measure with the sun. I used a compass and the sun. How do you disprove that? I would like to know how you disprove something that you measured using a compass and the sun. Physically. You're full of shit. Stouffer's Stovetop. Troll account. Anyway. Yeah, I don't think so. Should I make the status private now? Just put it to friends only. You don't have to make it private. Well, I guess that is making it private. But if you want to post something that you're worried about getting banned for, make it friends only. That's the trick. Although I did get a 3-day ban for something I posted to friends only, but it wasn't 30 days, it was only 3 days. And if it was public, I'm pretty sure it would have been 30 days. I mean, you know, whatever. Fuck Facebook anyway. Facebook's full of idiots and trolls. Drop that chart into Telegram. Okay. Oh, by the way, let me email this to you, to Carl. Carl said he wanted a protractor. So let me do that right now before I forget. If I can find your email. I may not be able to find it right yet. Oh no, there it is. Pretty sure that's you. Let me see. I better make sure. Nope, can't find it. Hmm. Maybe email me again, Carl, so I make sure I send it to the right person, because a couple of Carls are popping up in my email, and I don't know. I can't figure out which one is you. But I will put it in Telegram. I will put it in the Rebellion. I will put the protractor in the Rebellion. Let me just find it again. And it's also very important, well, it's very important that you print the protractor at 100%. Don't let it resize when you print it. Do you know what I mean? Don't let it resize, because if you let it resize when you print it, then the measurements will be off. Make sure it prints at 100%, and it might get cut off, right? Like the north and the south, the east and west might get cut off, but you only really need north and south, and you need to make sure you have this circle part, but make sure you print it at 100%. Or else these 1 centimeter, 2 centimeter measurements won't mean shit. And print it at 100%. And if you have a little metric ruler, just make sure that it's 1 centimeter between these lines. Do you know what I'm saying? So that it's the right size. Which? Is that all you got? Too bad we can't all float up as far as possible in our own balloons, see for ourselves, go to the places all governments see. Well, you know what? That's why, maybe that's why I was thinking for a while that that's why they stopped using Zeppelins, airships, was because it could just sit up there and just float, and you could have a lot of time to just sit there and ponder, right? Or maybe because the airship made it easier to travel further south, like Antarctica. But then I started looking further into like the temperatures and the gases and what the real problems were with the airships. And I don't think that anymore. I don't think that anymore. But it is possible that they did... I think what they showed us was like the infancy of the airship technology. And I do think it's possible that they have gone far beyond that. So like airships, as we know about them, I don't think are a very practical means of travel, right? Like it's not very practical. And, you know, it's kind of dangerous. They had a lot of accidents. I mean, I would say those airships, as they were not very practical, right? But it's definitely possible that they learned from that and the airship technology got better, but at the same time, I think their better airship technology would have made it much, much easier to see that the Earth is not a globe. You know what I'm saying? It's like, it'd be like a hot air balloon on steroids, like super, super high up there, right? Where it's just like, you're like looking around, you're like hanging out up there, hardly moving, the Earth ain't moving. You'd be like, come on, bro. Like, it would be way too obvious. Wow. Ted Summer, pilots only land and take off. The computer flies the rest of the way. So what happened? What did they do in the planes before they had computers on board? What did they do before they had computers? Because planes didn't always have computers on board. You know this, right? And not every airplane has computers. An airship that can land and sail in water, preferably. Well, what they could do, what they might, okay, here's one thing that people don't really talk about. Here's one thing that people don't talk about. People talk about them stupid airships, those antiquated airships all the time. Nobody talks about dirigibles. The fact that they could be having dirigibles that like stay up indefinitely, like aircraft carrier size dirigibles. Think about it. Like most of the stuff that people say is alien technology, it's probably just our technology that they don't tell you about. I mean, that to me makes more sense than it being alien technology from another world. It doesn't mean they're from outer space or from a ball in space, but they could be from outer lands or other lands, right? Well, that's still local. That's still here. And that's still like within the realm of being our technology. Talk about the the levitation stuff. That's right. I forgot to talk about the levitation stuff before, didn't I? Okay. Let me close this. I also was going to talk about crystals again because that dumbass Carl was on my Facebook page putting words in my mouth, trying to say that I said that because I don't even want to get into it. It's so stupid. It is so stupid. But I was going to go over like crystals and how they form and how crystals literally are rocks. Like this guy's like saying, "Hey Karen, you said that giant crystals grew the size of mountains and then turned into a rock." No, I didn't, you dipshit. Crystals literally are rocks. All rocks are crystalline structures. That's what I said. I didn't say a giant, gemmy, shiny crystal grew to the size of a mountain and then turned into a gray rock. I didn't fucking say that. It's obvious that he doesn't even listen to anything I say. He doesn't listen to a damn word I say. He just sits there with his arrogant, loudmouth, Eric Dubay worshiping ass, putting words in my mouth. Anyway, whatever. A movie the Congress has them too. Quartz is the most common mineral on Earth. Yeah. I mean, it's like, okay, so what I was going to say. Well, first of all, before we move on to all this, does anybody have any questions about this? And how many of you are willing to participate in an event where for a day or two we get everybody tracking their sun and getting that shadow measurement so that we can measure the difference between magnetic declination and what they measure? I want to see who's accurate and who's not accurate. Mine was not accurate. Cammy's was accurate. I'm gonna let remarks slide. Oh good. I'm glad you showed your face so I can take your wrench away, you fucking twerp. You are a twerp. You are a dipshit moron, Carl. Like the biggest dummy. Have you ever, I mean, he puts this post on Facebook and it's like, oh, rocks aren't crystals and crystals aren't rocks, blah, blah, blah. There's no mountain-sized crystals. And so then I post a bunch of pictures on his post where there's literally mountain-sized crystals where there's people harvesting the crystal from the rock to make tiles, slabs, sculptures, whatever out of the crystals that are literally the size of a mountain because all of the material is crystalline material and they harvest it. So then he deleted my comment and then said, "Get out of here with your lies." Those aren't lies, dude. That's literally how it works. Literally how it works. Putting words in my mouth, dude. You don't even know what I said. So anyway, Carl thinks that there's a difference between rocks and crystals. He doesn't think that a crystal is a rock. But literally, a rock is a crystal and a crystal is a rock. Now, the scientific definition of a crystal is a highly organized, pure mineral crystal system, right? Like, so like when you see like the terminated crystals and stuff, you know, in science, they have a very specific definition to what can be called a crystal. But everything, All of the hard material is crystalline material because that's what it means. It means to become hard like rock. Mountains grew. Yeah, I think they did. When the earth was formed. I mean, I can't prove it, but it makes sense to me. It makes more sense than there being a tree, but a tree can grow and then fall over and become a mountain. So what did the tree grow on top of? What did the tree grow from? You know, it just doesn't make any sense to me because a tree is an organism. A tree needs other things to sustain its existence, right? Like if I take a rock, a mineral, and just set it down, it's going to stay a rock or a mineral, right? Like once it forms, it's going to stay that way. A tree, if it doesn't have something else sustaining it, or if it doesn't absorb minerals from the ground and then become crystalline itself, right? Because the tree can become crystalline, right? Is the tree then, what's the tree then, right? So then if it can become crystalline itself, I know. Whatever, dude. Anyway, so I brought up this 1950s thing about crystals because it tells you.
You have to sharp edges. You can see I haven't ground the faces on this crystal or polished them at all. This is just the way the beast grows.
Just the way the beast grows.
Something out of nothing. Something with a shape all its own.
What did he say?
Which it decides to pressed by one thing. The crystal keeps growing, maybe for a week.
Crystal grows.
It keeps getting bigger, but all the time, it has plain faces, meeting in sharp edges. You can see I haven't ground the faces on this crystal or polished them at all. This is just the way the beast grows.
Just the way the beast
grows. It almost
grows.
seems as if you were getting something out of nothing. Something with a shape all its own, which it decides all by itself throughout its career. In order to grow a single perfect crystal as big as this, you have to take pains and let everything happen slowly. But you can see what's actually happening by letting things happen a little bit faster and looking at the business under the microscope. I'm going to take a solution of alum, which is just itching to deposit crystals, and make a little pool of it on the microscope slide, and then add a few little crystals of alum to give the alum something to deposit on.
Alum. Crystals of alum. Which also made me think, oh, I remember going to Alum Rock when I grew up in the Bay Area. Alum Rock. Alum Rock. Alum crystals. Alum rock. Rock and crystal are literally interchangeable as words.
And then get myself in focus and let her rip. There they are. You can actually see them grow if I turn now to a higher magnification. The little crystals keep pretty much the same shape as they grow, just getting bigger. Naturally, they all sit down on the microscope slide on one of their biggest faces. So you see the shape of the crystal depends mostly on what the crystal is made of, and not on its size, so long as it's free to grow in all directions.
So long as it's free to grow in all directions. It doesn't matter. The size doesn't matter. As long as the material is there and it is free to grow, then it will form. Okay? And my idea, my theory, just my idea, is that that's how it all began. The faceless deep, the formless deep, in the void. Okay? There was nothing. And then let there be light. The creator spoke, right? This is just what I think, okay? You can write it off. You can go wherever you want with it. But the creator spoke. Then everything has now been given the information. It has the information to grow. It has the direction. Boom. It starts to grow.
Crystals don't only grow out of solutions. They grow out of gases. Snowflakes, water crystals grow that way. And one of the most important places where crystals grow is out of melted materials when you cool them. Here I've got another powder you can get at the drugstore called Salol, which melts to convenient temperature. I'll put a little of it on a microscope slide. Then I'll carry it over here to the hot plate and melt it.
Pressure, temperature, all coefficients and how
And now
crystals
let's go
form.
over here to the microscopes. There's one growing, turning very slowly in the liquid as it grows because it hasn't quite sat down on the slide yet. It seems almost to push those flat faces ahead through the part that's still melted. Of course you know that the whole crystal isn't moving and shoving its front along. The liquid next to the face is becoming solid and adding itself to the face. But it's doing this in such a way that the stuff added on also forms a flat face, so the crystal keeps its shape while it grows.
Highly organized.
Now, I'll melt this back carefully on the hot plate so as to leave just a little rounded blob of crystal. That rounded blob will be a single crystal, but it won't have flat faces. And I want you to see what happens when this cools down again under the microscope. There it goes, growing the faces it wants to have, filling in the hollows and squaring off the rounded corners so that its boundaries are all flat again.
Filling in the hollows and squaring the corners. Now look at, but I like that one in particular because it's showing you like it kind of starts out as a mass, right? As like a crystal mass, like it sort of doesn't really have a form on there. And that is part of the beauty of like a lot of the things that you find, a lot of these crystals you find, like they're not all perfect. Like see how this one did not grow perfect, right? It's got flaws in it, but it wanted to, it tried. And if you go pick up a lot of these rocks out in nature and you start to look for that shape, if you know the crystalline habits and the forms, and you can start to see these geometric shapes are in just about every rock, even just a little piece, just like a side of it. It'll be like a half-formed hexagon or a triangle,
filling in
or
the
a
hollows and squaring
tetrahedron.
off the rounded corners so that its boundaries are all flat again.
It always tries to form. It
Notice
doesn't
now
always
what
start from
happens
one
when
end.
two crystals-
Like, you know what I'm saying? Like, when you say nature doesn't form straight lines, it doesn't start at point A and go to point B all the time. Sometimes it starts in the middle. Sometimes it starts here. Sometimes it starts there. But the end form is always going to be, you know, it's always trying to form that same shape. It's still trying to work and make the same form, but it can start from at any point in the shape, any point in space. It just has to start.
Bump into each other, so to speak. They don't push each other around. They just stop growing where they meet because they've used up all the stuff to grow with there. So the boundary between two crystals isn't necessarily one of the natural faces on either of them. The boundary line just depends on how the crystals happen to come together.
Scott Watts, coal can be turned into a diamond. No, it can't, dude. Coal is carbon, diamond is carbon, but they're literally different lattice structures. It's different. You can't turn coal into a diamond. A diamond grows like this, just like every other crystal you see. That's part of the lie too. Diamonds, you don't get diamonds by putting a lump of coal under pressure. You get diamonds because they grow in a crystal slurry, just like every other crystal.
When the whole thing is finally frozen, you have a dense mass of crystals. Maybe no single one of them shows any of its natural faces, but the whole mass is made up of crystals just the same. Almost all rocks are made up this way. Granite's a good example. Here's a hunk of it. Let's take a close look at it. You can see grains of the different colored minerals which make up granite. Here's a grayish grain of quartz. Here's a grain of pink feldspar, and the little black flecks are grains of a kind of mica. And each of these grains will be a single crystal. Notice that the three things don't mix together in the solid. They crystallize out in separate grains. Before I get through, you'll begin to see why. When you came in, I was melting some bismuth in a crucible over here, and it's been cooling. And crystals ought to have formed on the sides of the crucible so that when I pour off the part of the bismuth that's still melted, you can see them. Sometimes you can show up the crystals in a finished piece of metal by polishing the surface and then etching it carefully with something that will eat away the metal. Here's a cast brass door handle, which the manufacturer polished, and then over the years, the sweat on people's hands etched it, and now you can see the boundaries between some of the crystals which make up that door handle. In most pieces of metal, the crystals are much smaller than these crystals because they've been broken up when the metal was drawn or rolled or hammered into shape. But
metal is a crystal too.
Is crystalline just the same.
Metal is crystalline just the same.
Almost all, because they've been broken up when the metal was drawn or rolled or hammered into shape. But the metal is crystalline just the same.
Metal is crystalline just the same.
So almost all solid things are made of crystals.
Almost all solid things are made of crystalline. Say it again, dude.
Into shape. But the metal is crystalline just the same. Well, so almost all solid things are made of crystals. In fact, if you ask a physicist these days to define a solid, he'll probably say a solid is a bit of matter that is crystalline.
A solid is a bit of matter that is crystalline. Therefore, all mountains are crystalline structures. By definition. I rest my case.
Of course, that doesn't seem to get him very far, because somebody is sure to ask, what do you mean by crystalline?
Okay, Carl, I'm going to read your comment out loud because this shows your ignorance. Gonna go outside and watch a mountain grow. How long do I wait? You gotta watch this to the end because the crystal stops forming when the material is used up, okay? When the material is used up and the conditions have all been used up for that particular area, the crystal stops growing. It stops. It just doesn't manifest out of thin air. When it runs out of material, it stops forming. So the mountains, they formed and that's it. They're done. They formed because they have used up the material. The process has happened. It has been done. And now there it sits. That's why. Jesus Christ.
But he's got an answer to that one. The answer comes in two parts. The first part says all matter is made of atoms. The second part says, in crystalline matter, the atoms are arranged in regular order. I want to talk a little more about what he means by this and show you a little of the evidence for it. The idea is that the crystal is a pattern of atoms, a regularly repeated pattern of atoms, like the regularly repeated pattern of a wallpaper. If the atoms were flat and made a two-dimensional crystal, they might be taking up an orderly arrangement like this arrangement of pennies on the table. In 3 dimensions, they might be making an arrangement like these bearing balls, closely packed together. Of course, these close packed arrangements aren't the only arrangements the atoms might take. They're just simple examples of what I mean. Now, already, perhaps, you can see what these two ideas, the idea that a crystal is made of little units, atoms or molecules, all alike, and that those little units are arranged in the crystal in a regular array, you can see how those two ideas would explain what you've been looking at under the microscope. For instance, those alum crystals kept a symmetrical shape as they grew. Now suppose you had a two-dimensional crystal, like with a pattern of atoms like the arrangement of pennies. There are more atoms in solution all around it. But since the arrangement is symmetrical in the crystal, you expect pennies to add themselves on at the same rate here, and here, and here, and so on, because conditions are the same at all those places. The crystal will grow symmetrically and keep its shape, so long as nothing gets in the way and prevents more atoms from reaching the surfaces.
As long as nothing gets in the way and prevents it from doing what it wants to do, right? So this is where the natural entropy of nature starts to form the randomness of these shapes, right? That's entropy. That's nature. That's why everything is different. That's why These mountain range over here looks one way because it's got a different sort of mineral a concentration in its range. Another mountain range formed in a different shape because it has a different mineral concentration in its range, right? There is still the natural entropy of nature. That is that 1.618. That is that off-center division of the whole that creates that randomness across the plane, right? That's what it is.
Let me show you another kind of evidence for these two ideas. It's a kind of evidence which doesn't come from the process of growth. It comes from the properties of the finished crystal. This is the evidence of cleavage. If you've ever handled mica, you're acquainted with cleavage.
Cleavage. This is another important point.
The mica crystals you find in nature come up.
Now, this is another important point about cleavage. So whenever we go out into nature and we see these sharp lines, like these perfect squares or pyramids, yes, it's possible that it is man-made. However, it is also possible that those things formed naturally. Because remember, what you have to remember is that man imitates nature. We imitate nature. There's nothing new under the sun. We didn't make this place. You didn't make this place. I didn't make this place. This place was here made for us, right? And we imitate what we find here, and that is how we learn and grow and build. So the cleavage thing, this is important because rocks will naturally split in straight lines along points of cleavage, sharp, and it will look like it was laser cut. But it's not. It is a point of cleavage.
Apart easily in one direction and not in any other, so that you can split them into extremely thin, tough sheets. The mica acts as if it was made like a book, with a lot of leaves of tough paper. But if you actually try it, you'll get the feeling that there's no limit to the thinness of those leaves of paper. You'll feel that if you were skillful enough, you could split each leaf of the mica in two, and then each of those in two again, and so on. It makes you guess that the atoms in the mica are arranged in great sheets, that the atoms are bonded together very tightly in the sheets, and the bonding forces between the sheets are very small. Just the arrangement of atoms in sheets like that is a kind of orderliness. There aren't many crystals that cleave as well as mica. Alum, for example, doesn't cleave at all, but a great many crystals do cleave amazingly well. Let me show you the cleavage in this crystal. It's a crystal of nickel sulfate hexahydrate. It cleaves parallel to this face. I'll put the thing down on a little plasticine to hold it in place. I'll take a single-edged razor blade and direct the blade parallel to the face and give the back of the blade a smart tap. She comes apart. And now look at that, as flat as you please.
Amazing.
You may say, oh, you picked a special place in the crystal.
Amazing.
But look, I can cleave it again, parallel to that same face, and get a thin plate out of the thing. So it isn't a special place in the crystal, it's a special direction in the crystal. Now maybe you will say, oh, that isn't any special direction. You've got a sharp razor blade and you're cutting the thing apart with it. All right, if that's what you think, let me try the same stunt in a different direction. I turn my razor blade in a different direction and I whack it, and nothing much happens until I whack it a lot harder. And finally, of course, the thing busts. And there's no nice flat face. It's just broken apart like anything else.
Because of the highly organized manner in which these crystal systems form. Some of them will be stronger in one direction than the other.
Now let me show you the cleavage in another crystal, a crystal of sodium nitrate. Here's a crystal that cleaves in three directions, not just one. I can cleave it here, like this, and I can cleave it here, like this, and here, like this. By the way, you can grow both these crystals, nickel sulfate and sodium nitrate, by recipes given in the film notes in case you want to play around with the stuff yourself. Sodium nitrate has a lot of interesting properties. It has most of the properties of the mineral calcite. When big crystals of calcite were first discovered about 300 years ago in a quarry in Iceland, the scientists of that day got hold of some, and their studies of the stuff made the first big start in our understanding of crystals. As I say, sodium nitrate and calcite have many properties in common. In particular, they both cleave the same way. When those earlier scientists saw the way calcite cleaves, they had the idea that maybe calcite was made of tiny building blocks, all alike and all having the shape of little cleavage blocks of calcite.
Tiny building blocks.
You may be inclined to laugh at this and say that calcite, like all matter, must be made of atoms, and atoms don't look like building blocks. Okay, you're telling me. What do the atoms look like? Little hard round iron pellets? Don't let me fool you with those pennies and bearing balls I've been showing you. They just show where the atoms are, not what the atoms look like. For all I know, the atoms look like four-leaf clovers. I want to emphasize that those early scientists produced both of the main ideas which go into the picture of a crystal that we have today. First, they were saying crystals have an ultimate fine structure, the building blocks. We would call them small groups of atoms instead of blocks, but the difference is really more a matter of words than of anything else. Second, they were saying that structure has a regular array. The blocks are stacked up in a regular order, and they keep stacking up in regular arrangement as the crystal grows. It turns out that you can think of any crystal, not only crystals which show cleavage, but any crystal, as made of little blocks stacked up in regular array without overlapping on top of one another and side by side, if you choose the right shape of block. In the case of alum, the right shape of block is a cube. And you can think of the alum crystal as made of little cubes, all stacked up on top of one another without overlapping this way. Notice that I've made the main faces on the model of the alum crystal by stepping back the cubes as I piled them up. At first you might think that would mean that the face would be pretty rough. But you got to remember that these little cubes are really only a few atoms wide. Their sides are only about 1/10,000,000th of a centimeter long, and you wouldn't feel that roughness or even see it under the microscope. One of the things that gave early support to the building block idea was the fact that all crystals of the same stuff have the same angles between corresponding faces. The crystals might be very different in size. They might have grown at different rates on different faces so that they have different overall shapes, like these two alum crystals. Nevertheless, the angles between corresponding faces of all crystals are the same, so long as the crystals are made of the same material. It all suggests very strongly that each material forms its own building block, which gets repeated again and again as the crystal grows. Now, turn back for a moment to the microscope and remind yourself of what is happening while a crystal grows. Atoms are constantly arriving at the surfaces and adding themselves onto those surfaces in an orderly way, and they're doing this at an amazing rate of speed. The crystals you're looking at are growing fairly fast. Suppose a crystal grew at the rate of only a couple of millimeters a day, which is fairly slow. You can calculate that about 1,000 layers of molecules would have to be laid down per second on the surface of that crystal. And all the molecules have to be laid down in the right sort of order. I want to borrow a trick from Sir Lawrence Bragg to give you just a rough idea of some of the things that we think must go on as a crystal grows. Sir Lawrence blows soap bubbles. He blows them in a pan of soapy water, tiny bubbles which rise to the surface and collect in rafts. The bubbles behave a little like atoms because when they're floating on the water, they attract one another a little. And when they touch, they stick to one another quite strongly, as atoms do. But, again, like the atoms, they have a squashy sort of size so that they take up space. Watch how the bubbles collect together into an orderly arrangement. It's the same as the arrangement of pennies I showed you, the so-called close-packed arrangement. Notice that the rafts are made of large parts. All of the parts have the same sort of order, but the orderliness of the parts is turned in different directions, so that there are grain boundaries between the parts. This is like a solid made of lots of crystals which started growing in different places and finally joined. It's like the sail owl after it is all solidified.
The little 6 points around each dot, you see the hexagonal form coming out in the water already.
When you think of how fast the atoms have to get into order, much faster than this, the more astounding their achievement seems to be. But this will give you some little idea of what a hustle and bustle must really have to go on an atomic scale. Sometimes when the molecules are very big and have an irregular shape, they're too sluggish.
Carl, with your atoms question, are you not paying attention? Because just a few minutes ago in the video, he said, don't let me fool you with those pennies that I'm using. Atoms. He's like, nobody's seen an atom. He said, for all I know, atoms can look like a 4-leaf clover. He's saying that an atom is just another way to describe the building blocks that make up these crystals. And this is just scientists trying to define or quantify what nature is doing, okay, in the best way that they know how. So yeah, some of these idiots say atoms, but he even discredits that already in the video. So pay attention, dude. Jesus Christ.
To get themselves arranged into order. Then they congeal into a glass. A glass is very much like a liquid, but it's like a liquid in which the molecules are no longer able to move past each other. It has patches of order in the midst of disorder. The disorder is frozen in place, so to speak, and can't get itself rearranged into order. Liquids and glasses are pretty disorderly arrangements of molecules.
That's called amorphous.
And gases are the most disorderly arrangements of all. The only order in gases is the arrangement of atoms grouped in each molecule of the gas. Later in this course, you'll learn more about gases. But already, you can see why gases are so very much alike in a great many ways, whereas there are so many different kinds of solids. The only way gases can differ is in the kinds of molecules they are made of. But solids can differ also in the kind of orderliness which those molecules take up in the crystals which comprise the solid. I can show you this selectiveness actually happening in some of the materials you've already looked at. I'll melt some salal on the hot plate over here. There. And bring it over to the microscope and let it cool down so that it wants to crystallize. Then I'll seed the salal with a tiny crystal of alum. Nothing happens. No salal will crystallize on it. Now I'll seed the melt with a few little crystals of salal. And you can see the salal crystals grow, leaving the alum crystal unaffected. The orderliness of alum is not the right kind of orderliness for salal, and the salal simply waits until the right kind of orderliness is presented to it.
Like goes with like. Even in a solution with multiple crystalline parts. This is how you get stuff like granite, because granite, if you look up like the crystals, like I've done a lot of studying on crystals, right? Granite, even though it's made of crystal material and when they polish it, it's shiny and it has, you know, reflective properties. It looks crystalline, you know, like shiny, like gemmy crystalline. It's not considered technically a crystal because it has more than 3 crystal systems in it. It's a conglomerate. They call it a conglomerate, but it is no less crystalline than a diamond or fluorite or quartz or any of that stuff. Okay. And they do have different, and the different minerals do have different hardness, right? That's the Mohs scale, which also lends to them having different properties. And all of these different things, these different minerals, these are the things on the periodic table. This is like what everything is made of. Okay? So anyway, that's that. Go easy on the Jesus Christ. I have a potty mouth. Don't you guys know that yet? Don't you know I have a potty mouth? Okay, let me go back over here. Let me see. A rock fin. I think I'll start it as soon as possible. Okay, that conversation doesn't involve me. I saw on Globebusters that Mark Sargent was on Nat Geo watching globeheads do a test on water to prove the Earth was a globe and he wasn't flat smacking them. What's up with that? Well, did you watch the whole thing? They were. I mean, Rob Skiba was there, Mark Sargent was there, there was a bunch of people there, and National Geographic was like, okay, well, let's do a curvature test. And like, that whole thing was a setup. They were deceptive. They were dipping their striped flag in the water to make it look like curvature was hiding the bottom of the flag. And then you could see in the background where the horizon went past their flag in the boat. I mean, that whole thing, they came out there with the intent to set up flat earthers. We can never get a fair shake from these mainstream places. Don't you know what I mean? You're never going to get an honest investigation from these places. They're always going to come with the intent to prove that the earth is a globe and to debunk flat earth. They're always going to have that bias. This is why we have to make our own stuff. This is why I really applaud people like Shelley Lewis for putting out her series and doing that work on that, because, you know, it's not going to be influenced by these people with alternative globalist agendas, these mainstream places, right? And then also there's another couple, the Feziukes. They did that Orion film. They were at my event. Me and Mark Sargent are going to have them on Strange World on the 13th to talk about the movie that they want to make. They want to produce a high quality, flat earth documentary style movie. And they are flat earthers too. Okay. They came to my event. They hung out with us there both days. They're really cool people. And so, you know, you can listen on the December 13th. We're going to have them on Strange World and we'll talk to them about the project that they're working on. But this is why we have to do stuff like this. You know, we have to make these documentaries ourselves because we're never going to get a fair shake from them. Did Nat Geo just cut out Mark and only show him agreeing with the Globers? Probably. I mean, they always do their creative editing. That was the whole thing with whatchamacallit? Behind the Curve, right? They did their creative editing to turn it into a giant shit show when they had got everybody on board and agreed to participate with the understanding that they would be looking at a flat earthers with a fair and objective view. But they totally flip-flopped on that and you know, threw everybody under the bus. That was edited by Globers. And then everybody goes around and goes, oh, look at the movies you flat earthers made. You guys proved the globe in your movie. That isn't our fucking movie. We didn't have to go on the boat to see that they were full of shit, Carl. Proof's in the video. But then again, outward blame should be removed in general. Yeah. Look at this dipshit in chat. Hi, all, just your friendly reminder that we live on a globe, blah, bitty, blah, bitty, blah. Yeah, if you could go ahead and prove that, that would be great, instead of just parroting mainstream junk science BS. That's hilarious. Okay, I'm gonna go get more coffee. I'll be right back. All right, I'm back. Oops, I gotta plug my sound back in so I can hear myself. All right. Anyway, what's going on here? Mark G was hidden by Glowbusters. Trevor. Hey, Trevor7, good to see you. That's funny. It's funny, but you can see it too. Like if you go out and look at big rock formations, you can see the cleavage, like show up in the rock formations. Like, let's see. Let me see if I can, actually, let me look at Yosemite, because I was looking at Yosemite a couple weeks ago or a week ago, and there was a really good picture of Half Dome that actually showed cleavage lines in the Half Dome. And when you get these conglomerate rocks, it's not going to be a straight up, straight line like it was in that video where the cleavage is like perfectly straight, because the rock itself is a conglomerate. Like clearly this is not a pure mineral rock here, right? But you can see the layers. This is not the one where I saw the cleavage. I'll have to remember what rock I saw that at. But actually, I mean, if you see right here where Half Dome split, that probably is a cleavage line. That probably happened on a cleavage line. It probably formed as a complete dome, and then when it split apart during, at some point in the formation. And now, when I talk about this, I talk about it happening like it happened rather quickly. I think it did. I think at first it was probably very violent and quick, but that's just my opinion. Because you can see in the videos how fast the rocks form. And another thing too, it's just like trees, okay? The slower that the crystal forms, the harder it's going to be. So like anything that's got that it's harder on the Mohs scale, like, you know, that's probably going to be something that takes longer to form, right? Just like in trees, softwood trees grow really fast, right? So like pine trees grow ridiculously fast, and that is the soft, you know, replenishable wood, right? It's considered a soft wood. And they use it for building and stuff a lot too. But like there's other trees that have really hard wood, and you don't see people using them that much because they're harder to work with as far as like sawing them up and stuff, like beech trees. Okay, I've got beech trees on my property. They're called ironwood. The difference between trying to cut down a beech tree and trying to cut down a pine tree of the same size is huge, huge, because ironwoods grow extremely slow. And the wood is super dense and hard, okay? And the pine trees, like I said, they grow really fast and they're softer. So, you know, how quick they form too, I think has a difference in how the hardness of certain materials. I can't say that that's a hard, fast rule, but it does seem to be the case. Where was it that I saw cleavage lines? Anyway, I would have to go. I can't remember where I saw it, but if you look around at certain rocks, like especially like from high up, like bird's eye view pictures, even like on mountain ranges and stuff, you'll see where there's lines that run throughout the mountain range, like a straight line, a large line that's like miles long, but you can only see it from the sky. Thunder chicken. Video on Twitter that shows NASA heads unable to say where and when Artemis will be. Could it be that during the flood many of these formation happened? Emilios, man, actually, I think a lot of these happened from the formation of the plane itself, of this realm itself. But I do think a lot of the things that people are seeing are remnants of the flood, i.e. large petrified trees, possible mountains that could be organic material crystallized. Yes, I think some of the anomalous things that happen are remnants from the flood. That's my opinion, because when you have, like you can see in this video, the way that crystals form, right? It has to be some sort of fluid liquid solution, right? Like a super saturated mineral slurry. Sometimes, like the guy said, it's because the material is melted. It's a higher temperature, and so it becomes liquid. And then when it's allowed to cool, it becomes crystalline again and it forms crystals. This is how basalt supposedly forms, okay? Now, if you picture the formation of the earth, I mean, you know, I can't take what is in my head and like, you know, I don't know how to convey what I picture in my head to everybody else, but I picture, you know, a giant you know, like it explains, the formless deep, a great void, the formless deep. This the beginning original supersaturated mineral slurry that has all the different minerals in it, and then like you see in the video, you can have different minerals right next to each other in the slurry, and still one crystal will form, and the like mineral will go to like mineral, right? So it doesn't matter that it was all mixed up in the beginning. It doesn't matter, because like will go to like. If the conditions are right, and you know, the conditions would have been right, because the creator was creating. And so when it was electrified with the source energy from the creator, and then everything was given its instruction, then like minerals go to like minerals. And that's when you start to see these things start forming. So I would say that when the world was flooded, then you have created like a secondary supersaturated mineral slurry almost, right? Where you have a lot more organic material there. You have a lot of, you've had time and things were growing and everything already, where now you have the conditions set for organic material to be replaced by mineral and then become crystalline. So that, I think, is where we start. I do believe that there is a lot that was left over from that we see that are remnants from the flood. It makes sense to me. What's the life metaphor, Grounded Extracts? I want to hear it. The soft may grow tall quickly, but the true grain strength that stands the test of time takes much longer. Well, yes, very good point. How insightful of you. That's true. It's true. Hey, Benjamin. Hail, Ben. Hangman 1128. Is this the guy who looks at the trees? A little bit, but I don't watch a ton of it. I am familiar though. Cheers, Run Boston Bear. Have you watched Helio Sorcery? I don't know. Hi, Christy. Yeah, I don't know. I see some stuff, but it's, it's hard to catch it all. There's so much content these days. So I'm not, I never say that none of this could be trees or none of it could be that, but I would say that that's the exception and not the rule, in my opinion. In my humble opinion, that would be the exception and not the rule. And it would be as a result of what would seem to have been a worldwide flood. Because that's how you get, that's how you get stuff now that becomes crystalline. Like you find most of what people will find, like crabs and stuff. Like I've shared pictures of crabs and a lot of seashells and stuff that the minerals the organic material gets replaced and it becomes opalized, or it crystallizes, right? But, what was there first? The minerals were. So to me, it's like I can't see the mountains being trees, because a tree is an organic. It's an organism. It needs something to sustain it, and a tree needs a lot of nutrients. Like I live in an area that has a lot of trees. I tried to grow stuff in the ground next to trees. It doesn't fucking work because the tree takes all the nutrients. You know what I'm saying? Like you can't have a garden next to two big oak trees because the oak trees take all the nutrients. Trees need something to sustain them. So in my opinion, having a tree that size doesn't work with the proportions of the size of the realm, right? Like it just doesn't, to me, it just doesn't make sense. You know what I'm saying? Because it's a living thing and it needs other things to sustain it. So that to me just doesn't make sense. Now, I'm not saying that they couldn't have been bigger trees than what we know now. I just don't think they were like the size of mountains. Like the mountain base is not the tree stump. Could they have bigger trees than we know now? Yes. Were they as big as the mountain? I don't think so. That's just my opinion. My phone lines are open, by the way. I haven't even said it, but 848-222-2480. Yeah. When putting organic matter under running water, some of it petrified. Yeah. Yeah, but that's how, that's how these crystals form, right? You have to have a super saturated slurry. You have to have the saturation. And here's the important thing too, water. Water is a liquid crystal, okay? Water is a liquid crystal. Water literally is the catalyst to make everything else form, right? Like every other crystal is not going to form without some sort of fluid to move through. Like you've got it there, right? what's the fluid going to be? Well, the base fluid of everything on this realm is water. So water, being a liquid crystal, and it is a liquid crystal. I mean, I don't think there's many of you in here who will deny that water has memory, right? We've all seen like the I don't know if you guys have seen Vita Austin's crystallography, which is not what I understand crystallography to be. Like, she's freezing water and taking pictures. I guess technically it's crystallography, but I still have a issue with that word for some reason. I don't know why. But she takes pictures of the water being frozen after showing the water images, and then the water repeats the image. It's programmable. Water is programmable, and you know and when it freezes, when water freezes and becomes solid, it is a crystal. That is, and it fits the definition for a crystal because it does form in highly organized forms, right? Snowflakes, right? When you see a snowflake, that's water in a crystalline form. So water is the catalyst for all other things to grow, for all other crystals to happen, right? So when you get this organic matter submerged in water with other minerals, that then becomes, you know, the catalyst for these organic things to become crystalline. So yes, it does happen. I just disagree that the mountain is a crystal or the mountain is a tree. Because where's the rest of the tree? Where's the rest of it? Where's the fucking rest of it? Yeah, so you're grinding down an ammonite. Metallic. Ammonites opalize. Oh, those opal ammonites are the bomb. Oh my gosh, and they're so expensive. These, boy. Like, you can get these really big opalized. Look at that. Isn't that amazing? Look at, here you go. Here's a giant one. It's rainbow colored. Look at this. How gorgeous is that? Isn't that amazing? These are super expensive. Like an ammonite like this is many, many, many thousands of dollars. Many thousands. Oh, but it's so pretty. Oh, so freaking pretty. Water writes into the crystal dissolved into it. What happened to 666-1776? I still have it, but I use the call board because it's easier to do. It's easier to deal with the call board when you're working, when you're doing a live stream. It's just easier. It's just easier. Alligators' pituitary glands don't shut off, so they grow based off of their environment, food consumption. That's a weird comment to walk into. Tree topic adjacent. Considering trees typically grow larger with more space around them, would a person grow larger with more space around them? I don't know. I don't think so, because free-range humans don't grow bigger than humans who live in cities, right? So like right now we have free-range humans who are tribal people, right? Do you think that they should be growing bigger? Because they're not living in houses. They're living in the jungle amongst big trees, but they don't grow any bigger. So I would have to say no. I don't think so. I don't think so. I think that, well, I have to rethink that thought before I spit it out of my mouth. Growth density concept works with building muscle as well when applied to the body, right? So if you build slow, like they tell you, yeah, like if you do steroids and stuff and you do that, like you're not going to have that solid, muscle mass, where if you built over time, you built real slowly that muscle and you like with intent. That is true. If you want something to be more solid, yeah, it does take a little bit more time. I just got a hematite ring and a piece of shungite. Nice. All right. Do you guys want to keep talking about crystals? Oh, the levitation thing. Yeah, actually, I was watching a Trubber 7 members video when I saw this. This video that this guy played, and it was in relation to visualizing unseen forces, right? So they always have these different, let me see if I can find my, okay, that's not what I'm looking for. I need the, history. Let's see if I can find it. So they were talking about looking at unseen forces. A fascinating conversation, by the way. I really enjoyed that. But I kind of gleaned something from it that was flat Earth related, that blew my mind. Let me see if I can find it back here somewhere. Oof. Boy, it's way back there, isn't it? Good gracious. Let me look over here. Maybe I have it. Good God. Do I click on this much crap on YouTube for real? Oh, here we go. This is it. Visualizing ultrasound with the Schlerin optics. Okay, well, so what Schlerin optics is like whenever you see that video where you can see like the heat signature, the heat waves in the air, where you'll like see a candle and then you'll see the wispy heat waves coming off the candle, right? Well, Schlerin optics is basically a camera setup where you can see this stuff, right? You can see unseen forces, right? Or unseen ether perturbances, if that makes any sense. There's that weird shit that's even worse than steroids. Yeah. Okay. Okay, so in this video, so here he's talking about his Schlerin setup where he's got this camera lens and he's got a red filter and then a white filter. Okay, so it splits, it's right in the middle of the focal point of the camera. And then you have a white light that faces a concave mirror, not convex, concave, where it goes in. A concave mirror, and then the light reflects back to the focal point of the camera. And you can see the little light coming back in here, and then you get this image where the different refractions show up under different color schemes, right? So let me see if so right here you can see like one is hot and one is cold. So the density of the air changes from high density to the cooler air down to the hot air, right?
The density of the air changes from a high density in this cooler air down here to the hot air. Then the light is refracted and bent through the green filter, and it appears green. Whereas at the top, where we're going from a low density to a high density, the opposite happens. Then the light is refracted in the other direction through the red filter.
So basically, just this camera is showing you, that things going up and things going down. It's showing you the unseen things being influenced by the downward acceleration, bias, and pressure, density, and heat, and all that stuff, right? It's showing you what's happening.
So bring an ice cube.
So he's got this cool setup. Well, so there you see it's one's a heat gun and one's an ice cube. So you can see they're flip-flopped, right? So it's just showing you what you're seeing with this camera. So let me get to the cool part. Come on, jump forward. Okay, so the whole thing about this is he was showing, he's got this transducer thing, right? This transducer thing that puts out sound, and it was showing sound waves in like earlier versions of this video. It's like a 3-part little series. And in an earlier version, there's a little transducer that puts out sound waves that are inaudible to the human ear. And he's even putting hearing protection on, even though like in the video, he's like, I'm going to turn it on. You turn it on, you don't even hear it in the video, right? But he puts so it's this inaudible sound, okay, that's being emitted from this transducer. And then with the Schlerin device, you're able to see the sound, right?
So right now I'm turning up the intensity of the light, and lo and behold,
so watch this.
At the standing wave that we've seen before in white light. We can take another closer look at the standing wave that we've seen before in white light. So to do that, we're going to zoom in a little closer and see what colors appear, if any. So right now I'm turning up the intensity of the light, and lo and behold, we see alternating bands of red and green.
So alternating bands of red and green. So what this is, so this right here thing at the bottom is a transducer that's emitting a sound, okay? This thing above it is just a plate. There's nothing, I don't know that there's anything special about a plate, but the plate is there with the gripper held parallel to the transducer, which is emitting the sound up towards the plate. Now what this setup he's got doing now is the transducer's emitting the sound's reflecting off the plate back to the transducer, and it's like, you know, these sound waves are like perpetually bouncing in between this upper and lower plate, okay? Just keep that in mind. And also the red and the blue are different densities within this setup, okay?
So let's remember the red bands show a change in density of the air from less dense to more dense, and the green the opposite. So where those colors appear, that's where the largest changes in density, or pressure if you like, appear. Those are the pressure antinodes.
Pressure antinodes, right? So it's where areas in this space where pressure changes.
For our final demonstration, let's use our standing wave to levitate some small objects, in this case styrofoam balls. And what I'm interested in is to see where those balls want to settle down. So I'll turn up the power.
So we can't see it, right? Naked eye, you can't see it.
So I'm going to take a little styrofoam ball and place it in the space.
What?
And you notice the ball settles down in a red band. If I take another one, that one too is in a red band.
What?
Now I've got two of them in one area.
What is that? They're just floating. They're just floating. And they're different levels. Look at the different levels, and they stay there.
One of them is in a green band.
So the reason this blew my mind so much, because you guys know we've all seen the super cool, right? The super cooled conductor, where you get the super cooled conductive magnets and it puts it on a track and it stays super cooled and it spins around and it follows that track. Now, I'm not saying that doesn't play any role maybe in how possibly this realm works, the things in the sky, but this, I think, is a huge clue, because we all know that the Earth resonates, right, at like 7 point something hertz, 7.8 hertz or something like that. The Schumann resonance, right? The Schumann resonance. The Earth is constantly resonating. Now, if we have, something like this above, and the Schumann, that resonance there, that could possibly be creating these different pressure differentials higher up in the sky. And maybe, this is just me, just thought experiment. I don't know. I can't prove it. Disclaimer, just me thinking out loud. So if you have these different objects that are made of different minerals and have different properties, different electrical charges, and like, I can see this being part of the mechanism that drives what's going on in the sky.
So you see the balls settle down where there are bands of color. Those bands of color are rapid changes of pressure or density, and those are the pressure antinodes. That is where the balls settle down.
Yeah. I mean, it's just, I don't, and there's been a recent discussion too on Facebook where a lot of people are thinking that, like Dennis was getting all bent about people saying that the objects in the sky were holographic. Like, that's just one idea, Nobody knows what the lights in the sky are. Oh, I see Ben on the line. Thanks for calling Coffee Talk. You're on with Karen B.
Hey, Karen.
Hey.
How you doing?
Good. How are you?
Oh, fantastic. I almost hung up because I almost don't want to distract this conversation, but I was just calling about the water being programmable in crystals.
Yeah.
And just kind of puts... So I've been talking about this for a few years. If you look at Emoto's work, when he did his initial work and came up with his different crystals and the geometric designs, that was just taken from different natural water sources. When he wanted to go implement his own information, he had to go and distill the water out and remove out the water salts so the water didn't have a memory anymore. And then the water catches the signal, and he's flash freezing it as the water catches it. So the water itself isn't really programming. The water's the mercury. It's the philosophical mercury of the Earth level, and it allows signal. It catches the signal like mercury, and then passes it through into the salt, which the water had already dissolved and opened up. So now the salt is able to be written into.
Okay, that makes sense.
Because the salt. Right. So now that in my and this is one of the experiments I've been working on. I just got, like 3-4 months ago, got to where I'm working at negative 150, so I can hopefully flash freeze fast enough. But the idea is, of the different cellular salts, there's different structures. So the ones with the simplest structure should be the easiest to overwrite. And that's the whole deal with the salt. The water picks up whatever signal is super easily, but the salt has memory. So the idea is then to find the vibration of a little sentence, like say, "Hi, Karen," and I sit there and I blast that at this water with this specific salt dissolved into it. Then I evaporate out the water, and I can send the salt crystals to you. You put them back into water and flash freeze it, and that vibration will show again.
Trippy.
Right, because the salt's what's holding the memory. The water is like the computer screen or whatever, and the salt is like the hard drive.
Okay, that makes sense.
And then you are the sulfur. You're the one giving or receiving signal.
Yes.
Yes. But yeah, and this current subject is freaking fantastic. Absolutely fascinating.
Yeah, so it is correct then to say that the water is the catalyst to make
Right.
make these things
Right.
happen. Because it's not going to happen without it, right?
Yes. Exactly. Just like in the battery, the mercury, the energy doesn't flow without the mercury in there. You can have the positive and the negative, and they'll sit there. No mercury, no flow.
Right. Awesome.
You bet.
So what do you think about
We
the
love you,
levity?
Terry.
I love you too. You guys are the best. I was so happy that you and Christy were able to make it out and we got to meet in real life. That was the best part.
Oh, it was. We had so much fun. You guys' place is so gorgeous, and meeting Karen in person, you can't beat it. Just absolutely who she is, just and awesome to hang out with. It was so much fun. I can't wait till next year.
Yeah, buddy.
All right. Well, I'll let you go.
All right.
We'll
thanks.
talk to you later.
All right. Thanks for calling.
Yep.
Yeah. So there you go. That makes sense that the water is the carrier. It's the like the mercury. That does make sense because, and it also makes that be like water statement. No, water. I don't know if water's the medium, but it's definitely like part of the process. The process, nothing's happening without water, right? Like just like when you grow plants, you can grow plants with hydroponics, right? Basically just water and sunshine, right? Water and sunshine will make a plant grow. Now, putting it inside the dirt and giving the plant access to withdraw the nutrients and minerals from the dirt will make that plant better for you or more nutritious, but the plant can grow with just sun and water. And that should tell you right there that water is like, yeah, water is like ether. It's almost like liquid ether, but ether is a fluid. I don't know, man. It's just so bizarre when you start thinking about all of it, how it all works together. Like one, you know what I mean? It's really a beautiful thing. It's really beautiful the way that our realm works. It's fascinating. It's entirely fascinating. And man, I wish that we would have had discussions like this when I was in high school, instead of them feeding us all their like bullshit about space and heliocentricity and telling us that they have all the answers when clearly they don't. I would have been way more fascinated by science class in high school if the class was talking about shit like this, or if they had a lab set up where you could, create these sort of things where you could make these observations and learn about heat and temperature and pressure mediation and positive and charges and all that stuff. And I mean, they really have robbed us of so freaking much that it's sickening. But anyway, it did really make this place way more interesting than it used to be. Hydroponics doesn't work with distilled water alone. Fair enough, Thunder Chicken, right? Natural, like spring water will have minerals in it. That's true. But you can grow a plant with just water and sunshine. It mimics the Gunninga gap. I don't even know what that word is, my dude. Oh, hey, thank you for the tip, James Ritchie. Appreciate that. Cheers on Rockfin. The rainbow ammonite is yours for $90,000. Yeah, exactly. Exactly. But aren't they freaking gorgeous? Man. Like, You know, I don't really care. I try not to really be so involved with, like, care so much about materialistic stuff. But as a Taurus, sometimes it does, flashy things do catch my eyes. I can't help it. You know, everything, you know, I see that shiny stuff and I'm like, ooh, that's pretty. I want the shiny thing. And it's like, this is going to be $1 million. And I'm like, damn, man. Why does everything I like have to be so expensive? Yes, school would have been a lot better if it was truth-oriented, right? Right? I mean, clearly public school is designed to just crush your soul the way it is. The way it is now. I mean, there's just no ifs, ands, or buts about it. Yeah. The water opens the liner's crystals for use. The crystals set the electroconductivity for the energy to flow. 5 times the soil has minerals already. It's not the same as hydroponics with just water. Right, the plant won't be as good, but you can grow it. Keep up your... If you... I would love... you know what? I'll try to get back with Ken Wheeler. I'll try to message him again and see if he'll come on and talk with us. I kind of got bent because he was like, well, I don't know anything about flirtology. And I was like, motherfucker, I don't want to talk to you so you can talk about flat earth. I want to talk to you about magnetics and physics and like geeky stuff. I don't need to talk to him about flat earth. I already know earth is flat. So I kind of got bent because that was his reply. Oh, I don't know anything about flirtology. And I was just like, ugh. Did I even say anything about that, dude? I didn't even ask you to talk about that. So, whatever. I'll ask him again. I'm going to email him again, though. Very nice 5 times. I'm so confused. Okay, what time is it? 11:53. All right. Does anybody else want to call in? 848-222-2480. Yeah, all the learning and unlearning. Carrier. Last question. What are the spools on your left and right sides? They look like some strange steampunk style electrical shock devices. These are my microphones. Hold on. These, oh, you can't see it because I have my filter on. These are my microphones. Here. It's a microphone. That's funny though. I do like these mics though because they look like a car part. They look like, it reminded me of like you know, like, I don't know, sort of grungy. I don't know, they're cool looking. I like these mics. Those are my mics. All right. Can get smaller ones here at the gem show. Somebody sent me one. Do you remember I used to see a girl in chat called Friendellas Are Flat? Remember Friendellas Are Flat? That name? I used to see her in chat quite a bit. And then before, I guess she sent this. She sent me one, a little one. Aren't they cute? They're so cute. I love them. I love these because it's the golden ratio. It's the golden spiral. Anyway, they're super cute. So yeah, this, I thought when I saw this video, it just blew my mind because I was like, dude, that to me, like this could be the earth plane, the transducer at the bottom, resonating that sound up to the plate at the top and then creating that sort of in-between area with these different pressure differentials Because everybody says that the ISS is completely fake and they can't really be up there. There's still like a spot in my mind where I feel like they could be going up there. They could be going up there, but they're not orbiting the Earth. They're just going to one of these different pressure density levels, like a different, almost like I used to think maybe it was a different plane of inertia. Like if we had all these different magnetic fields and the plane of inertia, like where we consider ourselves residing here on the Earth plane, the plane of inertia, the area of neutral density, or like where everything's settles, right? The null point, because, and then, where was I going with that? Yeah. So different planes of inertia. But now, like when I see this, I'm like, okay, well, you don't really need different planes of inertia. That might not be what it is. It could just be different pressure densities caused by an inaudible sound being reflected between the Earth plane and the firmament, and then causing, and then within that, there's got to be something else that is probably influencing the movement of the objects, some sort of electromagnetic influence, or it could be mineral related to what the minerals are each of these objects are made of. I mean, who really the F knows? I don't know. But it's so cool to think about, right? Like this, that they're able to create something like this, right? And you turn it off, everything falls, right? I just found that extremely fascinating. Although Trevor was showing it for a different reason, it totally, just made me think, well, wow, this could be part of how our realm is working. Whenever you see stuff like this, gravity, he's defying gravity right there. So gravity, that tells you right there, gravity is not mass attracting mass, right? So that's obviously bullshit, because you wouldn't be able to defy gravity except for with another mass if gravity was mass attracting mass. So gravity is not just mass related. It's got something to do with the electrical charge or the properties of the object and where it wants to tend to, where it wants to gravitate toward. Gravitate. Don't pH balance in the water, then add acidic. You guys talking about poop? That's funny. Am I buffering? Because in almost every other instance, gravitate isn't electrically drawn. Even. Anyway, that's funny. I find it fascinating. Anyway, it's just another thing to think about. Maybe another idea about how, oh boy, I think my YouTube stream's gonna crap out. YouTube is being poopy. I don't have any warnings. Why does YouTube suck? Anyway, just something interesting to think about in regards to how the realm works. Just throwing it out there. It's nice. It's nice to have stuff to chew on. Got one on here. Yeah, for free speech. I'll do the something again. Just keep me posted. Okay, Dave Hinkle, great. Yeah, so back to this sun tracking thing. I'll have to figure out how that's going to be organized, because I would love to do that again and see if we can all take the time to measure our magnetic declination. What's this? Opal.
Expose it as much as possible. And it's already got a natural little split in it. So we're just going to give it a little tap and hopefully it'll separate on its own.
And weave Sam's magic yet again. Let's see.
Let's give it a little tap.
A surprise for the world. It's got a nice sound.
Whoop. Go on.
Go on.
Want to wet it?
Hose.
Some hose, some water. Okay. Nobody has seen this.
Nobody?
We're all going to be the first.
Oh,
Whoa!
That is absolutely unbelievable.
Oh,
Look at that.
That is
you never
so
get
cool.
sick of this stuff, do you?
No. I like to do this work every day.
Oh,
Isn't that amazing?
Beautiful.
Wow. I was not expecting that.
That's so cool. Boom. Taurus sun. Yeah. Taurus sun, baby. I like them shiny things. I can't deny it. I can't deny it. I love the shiny things. They're electroshock. Could you imagine me like electroshocking myself? That would be hilarious. Okay, but anyway, you guys, think about it. Think about it for a while. Think about it if you would like to participate in another sun tracking event where we're going to manually measure our magnetic declination. So instead of doing a sun tracking event where we try to like match solar noon up with time and date, which is pointless because most of the time when you take measurements, manual measurements of the sky, it's going to match timeanddate.com pretty right on most of the time. But I do think we could glean some important information if we got enough people in different parts of the world to participate in manual measurement of magnetic declination. Manual measurement of magnetic declination. It'll probably take 3 hours in the middle of the day of your day to do it. But I think it would be really interesting because last time when we did this, we did not do it with the intent of collecting specific information. Really so much. It was just kind of like, what are we doing? We're just going to measure this. You know what I mean? But nothing really came out of it. But I feel like if we did it this way and everybody, I feel like we could get some pretty cool information as far as like, you know, whose map matches declination and whose location does not. And maybe we could even sort of get some idea of the sun's path and maybe see if maybe get more of an elliptical shape out of it than a round shape. Anyway, I don't know. Yeah, everyone sees a different sun. Your sun is location based. That's why everybody has to do this in their own location. And then your location has to be known so that we can double check what magnetic declination is given for your location versus what you measured. And you just need a compass and this and a 5 centimeter nail or however big nail you want. There's a mathematical formula that you can use. You can actually, I think, let me check. Let me just check something. I might still have a video up where you can get if my sun tracking video, oh look, here we go. Here's the sun tracking video. And in this video, to help the people who are trying to draw the flat earth map, you will need a sundial compass or a sundial and a compass. Or a sundial and a compass. So a sundial compass or a sundial and a compass. It's perpendicular to the ground. You should already know the height of the object, or it should be easy to measure. Something to see the standard time like a smartphone. A camera to film what you are doing. And a paper and pencil to write everything down. You should put the sundial and the compass and the object in one line close to each other. If you're using a sundial and a compass separately, use the compass to orientate the sundial to magnetic north. Measure both the length of the shadow and the height of the object, and if you can do the math, great. If the math looks too complicated, don't worry. The measurements of the shadow and the object will be enough for them. They will do the rest. Use a camera. Right, so if you don't want to do the math to figure out the sun angle, well, actually you don't even need this angle. What am I doing? You don't even need this, because we don't even have to measure it. You just have to plot it. Because this is actually measuring the sun angle and elevation, and you don't have to do all that. For this, you're going to set it up the same way. Let's see. Where you orientate it to north. Let me see if I have it here. Okay, so here's your shadow and your gnomon, right? So you just orientate it the same way we orientated it when we did this sun tracking, but you don't have to do this math. But if you go to this video, how to track the sun, flat earth research, in the link, there's a link to the Google Drive to download this file. Is it still here? Ugh, no. Oh, here we go. This sheet right here, this link right here. Okay, boom. So if you go to this video, and then it says right here, it says print this sheet out and place your object in the center to find the shadow direction and length easily. This link right here goes to that. Or if you go into my Telegram group called The Rebellion, I just uploaded it there too. In fact, let me pin it. I'll pin it so that it's here. Pin to the top. Pin. Okay. So if you go into the Telegram group, The Rebellion, I have pinned the protractor so you can download it there in PDF form. And remember to print it out at 100%. Don't let your printer reduce or shrink to size or any of that crap. And then you'll be able to do it. So probably what I'll have to do is make another video explaining how to collect the information to do the sun tracking. But I think it would be really cool if we could get a lot of people to do this. Need a water level too, right? No. No, you don't need a level. The level was for if you use a sundial compass and it has these little legs on there, and you do have to make your compass level with the sundial compass. So I was using a level to level my compass, but you don't even have to do that. If you just have a compass and you use your compass to align that sheet to north, and then have your gnomon in the center, and then just plot the sun path for like I said, start before noon and then go till afternoon, you know, because you want to see the shadow go from the long part to the short part and then back to the long part again, so that we can pinpoint that period of time when the shadow is the shortest, and then find that point where it's going around in the center. So yeah, you don't even have to do it that way. You don't even have to measure it. Does that make sense? I'll have to plan it on like a, when should we do it? Oh, I don't know. I'll have to figure out a plan when we could do it, and then I'll have to set up the stream, and we'll have like a full day. I mean, really, we don't have to do it for 24 hours like we were doing the sun tracking because we're not looking for the same information. We could just do it. I could just do a stream where I could do a stream where it's like a long daytime stream and I can have a Zoom room set up, and then people from different places can sign on and join the chat and join the stream while they're doing measurements through Zoom, and we can all chit chat about it and stuff if you want. Or you guys can just all do it and turn in your information. But I don't know. But I think it would be fun. No, we're not. But this isn't about curvature. This is just about trying to figure out where the deception is in the mapping and the magnetic declination, because I do think there is some deception there. And the only way for us to find out for sure is by doing this, right? We have to go and like manually measure and figure out what, if what they're telling us is accurate. And it's a pain in the butt, man. It's not fun. It's boring. It is not fun. It's not fun. It's geeky. It's slow. It's kind of boring. But I feel like the information that could be gleaned from it would be fascinating. At least I would hope so. I think it would be cool to do. And, and then if we just do it once and then we're just like, that's a big nothing burger, well, then at least we looked, right? So, anyway. Maybe using DRTRH's app would benefit. Yeah, you know what? That's a good idea. If David wants to help, then what I could do is I could make a video about it, and then maybe he could feature it on the app, and then people could, if they want to participate, they could do it. Because the more people that we get to do it, then the more information that we could derive from it. Obviously, you know what I'm saying? That would give us a lot of stuff to go through for a while, and it would be interesting to plot it out and look at it, how it compares to the map, to the AE map, because everybody says, oh, the AE map is wrong. Well, it could be. I mean, I'm not going to sit here and say for sure that it is 100% correct. It's just the closest thing we have. I mean, it could be wrong, but let's find out, man. Let's test it. This to me is how we're going to find out. It's the closest. It's like, you know what I mean? Because years ago when we first got into this stuff, I remember going and looking into cartography and how to make maps and all that stuff, because that was why I contacted Zach in the first place, because he made that video and he was like, let's draw the map, let's do it, right? And I was like, yeah, man, where the fuck are we? Let's draw this map. Well, it didn't take us very long to figure out that we were not going to draw a new map from scratch. We're not going to do it. It's way too difficult. We don't have the means to do it. I mean, it's just not going to happen. What we have to do is take the information that was given to us and figure out ways to dissect it piece by piece. In my opinion, this is one way to start dissecting it piece by piece. So that'll be a thing that will be coming up soon. We'll do it. We'll do it. Yeah, we're the experiment. Great. I think it would be great. Greatest effect would be in the southern hemisphere. I mean, possibly. I mean, and it would be really interesting to see from their point of view too. Anybody in the southern hemisphere doing it, that would be fascinating. Time to get to work. All right, Ben, have a good one. All right. Well. James, oh, okay. Thank you for calling Coffee Talk. You're on with Karen B.
Hey, am I on?
You are.
That's awesome. My name's JT. I also go by Run Boston Bear. And Karen, you're a legend. I love listening to your information. I think it's awesome that you helped out with the baby shower the other day with Austin and Kai. And this journey's been amazing.
Yeah, well, thank you.
Man, I'm only 10 months into it. I found out about biblical cosmology 10 months ago, and then all other deceptions just started to flood my way. Like, it seems like they're innumerable. It seems like everything's inverted, everything's twisted, everything's wrong, history's wrong, and it got really scary at first, but now I'm at a real peaceful place. Like, I freaked out because I didn't know what it all meant for me personally, and now I'm realizing love and connection and taking care of my kids and just being in communion with people that care about the truth is the most important thing you can do to be healthy.
Yeah, I could not agree more.
Yeah.
Wow,
Oh, but
fascinating.
earlier I had to go. I was going in for a physical, and after my wake up, it's like, no, I don't want the flu shot. Nope, I'm not interested in a booster. Nope, I'm going to pretty much just let food be thy medicine. I'm going to eat clean, going to filter my water. I'm going to try to stay away from the 5G and the AirPods. And my doctor was looking at me like, oh, you've had quite a change. And I told him, yeah, I've been researching a lot of things. I didn't drop, flat earth on him because you have to kind of like let the spirit guide you. Not everybody's ready to have that conversation. I told a few people, and they've wigged out on me and gotten mad at me and angry and called me all kind of names. But if you listen, some people will be like, yeah, man, I've really been into homesteading lately. And I'm like, oh, so you're a truther. And they're like, oh, yeah, I'm a truther. And then you can say, like, oh, what do you know about the shape of the earth? And they're like, oh, yeah, I've been looking into it. It's really crazy, the tidal wave of people that are waking up right now.
That's amazing. That's amazing.
Totally.
That makes me happy. So 10 months. So you woke up to flat earth first?
10 months. Yeah, so I was in college when 9/11 happened, and I saw it on TV. I'm 42 now. I'm the same age as Owen Benjamin. And actually, my best friend Jeremiah and Nikolai are both 42. I think there's something about 80s babies that, didn't have technology and was just playing outside all the time and, having friends and just having that kind of fun. And then we got introduced to the information age and the internet. There's something about the 80s babies that I think can get let loose from the lies a little bit easier. But I shot a message to a buddy of mine on Instagram. It was one of those classic, here's the ball earth, here's the sun right next to it. Look how big the sun is next to the tiny earth. Hey, here is a massive sun, bigger than our sun, and here's a black hole bigger than all that. And I was like, sending it out to 5 or 6 people. I said, look, the heavens declare the glory of God. Isn't our God big and powerful and mighty? And like most people were like, yeah, God's awesome. My one friend, Jeremiah, that I went to high school with, he responded, he said, I don't think that's scientifically provable at all. I think it's actually a fairy tale. That's how the flat earth journey began for me, because I was like, what are you talking about, dude? And I didn't laugh at him. I just didn't know what he was talking about because I hadn't heard about flat earth. So I told my best friend Nikolai, hey man, Jeremiah told me this weird stuff. I don't even know what he's talking about. And he laughed so hard. But I sent him the Matt Long video called Dear Pastor, and he sent me a couple of your videos. I think your spherical video was mind-blowing. And my friend cracked up at first, but 3 weeks later he called me back. He's like, dude, we got to look into this. And so 2 people woke up off of my one friend's challenge to my Instagram post, and we're like sold out, totally awake.
That's awesome.
Yeah, it's crazy.
That's fantastic. Well, we're glad to have you.
I attended the Mount Meru. Yeah, well, thank you. Yeah, I look forward to learning more. It's like you have to unlearn all the lies before you can actually start learning about this realm.
Yes.
So it's been exciting. I attended the Mount Meru Summit and listened to a lot of great speakers. And when you were talking about water earlier, I don't know if you've listened to Amanda Vollmer's talk from the summit.
Yeah, I was there.
It was
I
fascinating.
Watched it. Yeah, she had a good talk. Water is fascinating. Yeah.
And then have you looked into Cal Washington much?
Yes.
So that dude knows about law and spiritual law like crazy. Mm-hmm. And I think there's even something like if you declare something at the ocean's edge, like read something out, the power of your words go like across the ocean, up the firmament to God. It's something I heard that like it blew my mind.
Well, that's an interesting thought.
And another thought is like people say grace before food. They like bless the food. I always thought that was like, thank you, God, for this food. Thank you, help it to nourish my body. But when you speak positively, or when you're basically a positive person thinking positively around water, it does structurally change. And I did not know that. Didn't know it at all.
Yeah.
And then you consume it, and it becomes part of you. And it's totally helped me to drop the drama and drop the anxiety. I mean, the knee-jerk reaction is to be freaked out about everything and worried and anxious and all that stuff, but that's also the enemy at work trying to mess you up.
Yes.
So if you can just find those people that understand who you are and love you and connect, and don't listen to the bots and the haters and the paid shills to hate on Flat Earth, like, yeah, you got to confront them a little bit, but don't get tied up trying to, like, prove to the world what is reality. Just be in reality, be the light, be the truth, look for the truth, seek it out, and talk with people that are willing to talk about the truth. You know what I'm talking about? Then you grow and you actually develop.
Yes, absolutely.
Sorry, I didn't mean to bombard. It's just when you go 2 years thinking COVID was a real deal, and you're scared, and you're locked down, you're wearing a mask, and you don't know what the truth is. And I'm a stay-at-home dad with 3 small kids too, so I don't get to adult much. And then, you know, my own dad didn't want to hear about NASA and the moon landings being fake, and our realm not being what it is, a stationary extended plane. When you kind of get not disowned, but when they're not interested and they get mad, when you have the opportunity to talk to somebody that thinks like you just get all excited and pumped.
Yeah, for sure. It's,
you know the deal.
Yeah, that's fascinating though. Like how, you know, and what you said, like how it seemed scary at first. That's how I felt when I first woke up to all this stuff. I was like, I was probably the closest I ever came to depression. I was like, oh my God, you know, I thought, it was really scary, like you said. But then after you walk through that and you realize that, well, now it just means I know the truth and I don't have to be afraid of the lies they tell me. And then it becomes like relief, right? It becomes like very freeing and relieving, right? Now you're like, oh, well, space isn't trying to kill me. And there is no mystery bug trying to kill me. And, you know, most of the things that they tell you to be afraid of, you don't have to be afraid of at all. That's the best part.
Yeah, like there are no nuclear bombs. Like, where's the radiation? I love Owen Benjamin's the what is it? It's the nuclear hoax is maybe what it's called. Yeah. And so I have a Christian background, and it's funny because I was like, well, I don't have time to go into all of it. I lived for 27 years being my own God, doing whatever, trying to find joy, trying to find peace, trying drugs, trying partying, just like seeking everything the world had to offer to find contentment and to find who I was. Well, obviously, if you're just lost in the world of addiction of anything, you're not your true form of yourself. You're also lost. So there's like evil out there trying to deceive you into not being your true self. And then you've got these elitists and the government and pedophiles and just all these like completely broken people that are run by the evil trying to mess up who you really are and lie to you about who you really are and where we're at. So yeah, it got super scary, and I realized you don't have to go down the rabbit hole very far. Like if you know Hollywood has some bad stuff in it and the government has some really bad people in it, you don't have to research any farther. Just know you don't want to look that way. Look at the earth. Look at where we live. Look at each other, who is alive, who is awake, who's making a difference, and you'll stay out of trouble. You know, your path will be a little straighter.
Yeah, I agree, because then you're not looking to these outside sources for guidance. You begin to trust yourself and then become more responsible for yourself and make your own decisions, and then therefore be happier with the decisions that are made because you made them from an informed point of view. Right. Yeah. And
even the collapse of you know how people are scared of like the economic collapse or end times deceptions or even like the mark of the beast? You don't even have to play that game. The evil one and the evil that's out there can't make you play the game. So like what Owen's doing is he's like, hey, you need to know 20 people who are growing food or who have skills and who are awake. If you know those people and they're nearby enough, if the crap hits the fan and you don't have any access to your bank account and they say you can't buy food here if you don't get the jab or the whatever, the injection or the, thing in your hand, say, okay, I'm not going to play that game. I'm not going to buy food at the grocery store. And then you got to lean on each other. So really there's no reason to fear at all. They're just trying to trick you into being scared always so they can control you.
Yeah. And people also have to learn to not be afraid to be adaptive. People are very adaptive. Don't worry about it. If things change, you'll adapt and move on.
Yeah, for sure. Well, I appreciate the chat. I hope to meet you in person one day. I'll come to one of your things you put on. I expect to meet Dave and you and Matt Long and Austin and Kai. Like, we're family, really, in this battle.
For sure. Yeah. All right. Thank you so much for calling.
Oh, it's fun. I'll call again.
All right. Cheers.
All right. Cheers.
What a great call. Can you imagine? I mean, he's spot on, right? Only been here for 10 months and woke up after COVID, being stressed out by COVID all that time. See, it's like, it's sometimes, you in one respect, all the stuff that's being perpetrated on the masses is freaking horrible, man. It's horrible shit. Horrible, horrible, evil shit. But at the same time, it's good to see that some good things are coming out of it, that people are waking up and, starting to realize that they don't have to believe the fear that the lies, the fear-laden lies that get pushed on us every day, the spells being cast. Right on, man. Another spell breaker added to the group. Well, we'll take it. Cheers. Awesome. All right. On that note, you guys, I'm going to wrap it up. I really appreciate you guys spending your Moonday mornings here with me, Karen B. On my channels, I will be back here tomorrow evening with Mark Sargent for another episode of Strange World. And like I said, not tomorrow, but the following Tuesday on the 13th, we're going to have the Feziukes. David and Sarah, I think it's David and Sarah Feziuk, and they are the ones who made that movie, the Orion film, that I premiered, or not premiered, but I did a viewing at my event. It's also been on the Flat Earth or Founded Earth Brothers channel. I still want to call them the Flat Earth Brothers, but they're Founded Earth Brothers. The Founded Earth Brothers channel. And they're a really nice couple, and they're flat earthers, and they want to make a very nice professional documentary style film about flat earth. And so we will be having them on to discuss their ideas for that on the 13th. But we'll also be on tomorrow, as usual, with our happy, shiny selves. And I guess that's it for today. Do I want to say anything else before I hang up? Before I end? I always forget. Oh, I should have said such and such. I don't know. I guess I don't have it. Anyway. All right, you guys. Thanks for being here. See y'all later. And for those who wish to send me stuff through snail mail, you can send it to P.O. Box 10, Earl, North Carolina, 28038. There are also links below for Flat Earth merch, and you can send me donations. And I do appreciate all the support. Sincerely, thank you very much. Also, please go to flatearthfestivals.com for all information about upcoming Flattoberfests and Flat Earth-friendly local meetups. If you are organizing a local Flat Earth meetup, email me at flatearthfestivals@protonmail.com with your meetup information to have it listed on the website for free. For everything else, you can email me at karenbfe@protonmail.com. Thank you for being here.